I need you on page 130.
Didn't you say no reason until today's break?
Yeah.
I'm kind of excited. He's fine.
All right. Corresponding parts. Anyone want to tell me what that is? Okay. All you did was rearrange the words for that. Parts that are corresponding. What does that mean?
So they are
The same length.
Okay.
Segment.
Okay. Okay. So we're talking about two figures here. Okay. So if I have two congruent figures, then our corresponding parts would be our matching sides. Like you said, segments. Okay. And what else does a shape have? Yeah. So we're gonna start dipping our toes into congruent triangles. Now, this week and like moving into our Monday quiz, we're going to talk about like, hey, we know these are congruent, okay? Well, not next week, after Thanksgiving, we'll actually prove, here are two triangles, we're gonna write a proof that they're congruent, given a certain amount of information, okay? So we need to understand some properties, okay? We have three properties of congruence with our triangles, okay? First of all, we have the reflexive property. You remember the reflexive property? When basically the same thing is congruent to the same thing, right? Okay. We also have the symmetric property that we can use with congruent triangles. So if triangle ABC is congruent to triangle DEF, then we can write it backwards. Okay. Then we also have the transitive property. Okay. We can say, all right, ABC is congruent to DEF. DEF is congruent to JKL. So, hey, sandwich, the breads are congruent. You don't like that analogy? Ben's making fun of me. It's fine.
Stop making fun of people. Someone says something.
Okay, I would like you to where it says notes to draw this really awesome picture that I'm about to draw. Okay. Now, after Thanksgiving, we'll talk about some shortcuts for proving triangles congruent. But right now, if two triangles are congruent, then their corresponding sides are congruent and their corresponding angles are congruent. I don't know if I see all of that happening here. Do you? Do we have two triangles that have three congruent sides and three congruent angles? Do they not? Question. Is BD congruent to BD? Ah, it is. So if BD is congruent to BD, then wouldn't that give us our third side? Yeah. So we could say triangle ABD is congruent to triangle. How would we have to name the other one? If I named the other one ABD, then we would have to name CBD. Did you say O? Ben, are you good? I was like, that looks like a D, doesn't it? Okay. One cool theorem that we do have sort of feels like common sense. If we have two angles congruent to two angles, what has to be true about the third? Oh, they're gonna have the same leftover amount to get to 180, right? Common sense? Okay, turn to page, I don't know in your folder, I'm gonna guess 5, but I'm probably wrong.
I was too, so I don't think so.
Okay. Okay, is it page 1? We haven't done, oh, we haven't done anything yet. Page 1.
He's trying to.
Page. Spooky. CPCTC. Well, CPCTC means corresponding parts of congruent triangles are, what's the last C? Corresponding parts of congruent triangles are, yeah. If I have two triangles that are congruent, then all of their corresponding parts are congruent.
Can't two triangles that are the same thing not have corresponding parts?
Huh?
So we're using CPT whatever to say that two triangles that have the same parts, but if we look at the same thing, the two triangles, can we see based off the marks that are put on them that they're congruent to begin with?
Well, but like, what about this right here? Here I'm telling you that these two triangles are congruent. So I don't have a picture, but I know their corresponding parts are congruent. So how am I supposed to know what angles are congruent to what angles? Well, when we write our congruent statement, J corresponds with P, K corresponds with Q, and L corresponds with R. So we know from this that angle J is congruent to angle P because they're in corresponding places in the name, okay? Angle K is congruent to angle Q, and angle L is congruent to angle R. our sides. We know that JK is a side. What would be its corresponding side? PQ. Right? JK and PQ, they're in corresponding places. All right, we can also write KL as a side. What's its corresponding side? QR. Okay. Hey, that's not nice. Brayden, what would be our third side from the first triangle?
L or JL.
Okay.
PR is congruent to PR.
JL is congruent to PR. Is that the last one we're missing? Okay, good. Now, there is more than one way to write this congruency statement up here, okay? We have written that triangle JKL is congruent to triangle PQR, and it makes us happy because they're in alphabetical order, right?
Yes.
However, if I wrote triangle KJL is congruent to triangle QPR, that would mean the same thing. Notice how my corresponding pieces are still in the same spots. I just have my letters in a different order, but it means the same thing.
So could we still like do the same thing even if it was like this?
You mean like what we did with the angles and the sides? Yeah, we better be able to, okay? We said angle J and angle P are congruent. We'll notice how J and P are still in the same place in our congruency triangle statement, okay? Okay, so how about you do this same thing for number 2? Give me the angles, give me the sides. Oh, you just tell me you're done.
No, I swear.
All right, Sam, give me an angle statement. Let's do congruent. Okay, angle W is congruent to angle E. Great. Alex, what's another one? Okay, great. Nora, what's our other one? Great. Okay. All right. Alexa, give me a side.
WX is congruent to EF.
Great. Harvey, give me another side. Awesome. Ben, give me another one.
WY is equal to PG.
Congruent, but yes. Okay. All right. And then Clark, can you share with me your different congruency statement for the triangles?
I mean, I put Y, I put YXW, and I put GFE.
Good. Does that work?
Yeah.
Okay, all the same things are in the same places. Sounds good to me. Okay, now let's actually go to one with a picture. I'm telling you in number 3 that we have 2 triangles that are congruent. So we need to complete the following statements. So here's something that I would do, okay? If KPM is congruent to AYC, I think it might help me if I say like, ooh, okay, well, K and A are congruent, P and Y are congruent. I think that just might help me visually. And it might help me, KP and AY are congruent sides, PM and YC are congruent sides. So that's just gonna help me visually, okay, when I look at these statements, okay? But also what's gonna help is if we look at the order in which these appear, okay? What segment is KM congruent to? What? Okay, it does matter what order. It needs to be AC because the K corresponds with the A and the M with the C. Okay, from the picture, KM, so it goes from the one swoop to, I did not mark the swoop. So over here, AC goes from the one swoop to, I didn't mark it. Okay. CY, side CY is congruent to what? Very good, MP. We need to make sure that those are in the same order. So CY, MP, or I look here, CY, okay? MP would be that same order with how we draw it out, okay? PK. Yeah. No, okay. Then that one was for you. For you.
Sorry, I just didn't want
I'm the one getting made fun of. Okay. All right, angle Y. Which angle is angle Y congruent to? P. Okay. What about angle K? Angle A. Ooh, I like this one. Angle ACY. KMP. Okay. Now we have some triangle congruency statements. So if I call the triangle MPK, then the other triangle would be called? See ya. Okay. See, that's what I was wanting. YAC. Okay, got this. Okay. All right, so now in number 4, we have the same thing where I have 2 congruent triangles, but now we have some measurements, okay? Well, here we go. I know that S and B are corresponding. So what does that mean about angle B? It equals 67 degrees. Let's mark it down. Since S and B are corresponding angles in 2 congruent triangles, they're going to be the same. Okay. T and F. Well, we don't know either one of those, but W and N are corresponding, which means if N is 82, W is also 82. Okay. But Brayden, help me out. If we have 2 angles of a triangle, we need the third. So what angle would this be? Ooh, Harvey hasn't. So what's 67 plus 82?
149. 31.
Okay. All Now, is there anything else we can mark up? Okay, we can mark what F is. What about the sides? Do we know some information about our sides? WT is 14 centimeters, and we know that because WT and NF are corresponding. What else? BN is 9. Do you agree? Okay. Do we know BF? 17. Okay. Now we can answer every single question over here to the left. We know BN is 9. TW is 14. And BF is 17. We know angle W is 82. We know angle B is 67 and angle F is 31. $25. Thank you for reminding me that it's a Wednesday.
I forgot about that.
Sam, you're being annoying. Stop. Thank you. All right, so we're gonna skip number 5 because tomorrow's the day we're gonna talk about isosceles triangles and what's cool about them, okay? So let's go to number 6. Number 6, we need to solve for x, y, and z. Okay, so UVW, the triangle, is congruent to triangle TSR. So let's go ahead and mark this triangle up so we know what sides correspond with which. UV is right here. What does it correspond with? UV. TS. This here's UV, here's TS. Okay. What about VW? VW corresponds with SR. So I'm going to put them with 2 little tick marks. And then UW, I'm going to put 3 little tick marks, is going to correspond to TR. Okay. So what do we know? We know that 12x minus 7 should equal what number? And if 12x minus 7 equals 53, then 12x equals 60. So x equals 5. Okay. Since we know those purple segments are congruent, then we can write that 5y minus 33 equals 57. Yeah? Do you agree with that statement? It's 11:11, make a wish. All right, so 5y equals 90, right? So y equals? Do you agree that it's 18?
Yes.
Yes. Yes. Okay. And then our last algebra statement here, we have, what is it? 3z plus 14 equals 50.
Whoa.
Z equals 12.
Cool.
I think 12, guys.
You think it's 12?
Yeah.
Hey guys, is it 12? No way. It's 12.
Stop it now. I established.
Okay,
I found that pretty.
we apologize. Here we go. I know that this seems kind of strange, like I'm matching up letters together, I'm matching up sides together. But this is going to be really important after Thanksgiving when we're actually like looking for congruent triangles, or we're looking for like proving that these two sides are congruent. Okay, so your homework,
Is it page 131 to 132?
So page 2. Please say it's.
it's your
page 2.
student journal,
Oh,
131 and 132. It really does.